Okay, I believe I'm live now. Can people tell me in the chat if they can see me? Okay, let me move to chat as well. Okay, I am live. Okay, perfect, cool. Okay, so in today's stream, we are gonna be solving the May Long challenge. As you all know, it's a 10-day long challenge. So we will be solving most of its problems. Okay, these are the problems. I'm pretty sure most of you must have already like tried to solve at least all the problems. Okay, okay, let's wait for 2 more minutes to for people to join. Okay, okay, let me increase the font size for everyone. Okay, I hope this is better now. Okay, and in the meantime, let me just tell you about the new batch that is starting in Unacademy. So the name of the batch is Samurai, and it has actually already started from 11th. And there are other batches as well. So we have interview batch 6 months course, which is starting from 17th, which is today. And then we have Samurai, which has already started on 11th. It's an 11 months course. Then we have Adroit, which is a 9 months course. And then we have Gladiator, which is an 8 month course. So I'm going to be telling you about all these courses now. So before that, like as you all know, in Unacademy, you get a structured learning path and you get everything in a subscription. So you get for one subscription, you get every access to everything. Okay. So apart after that, so these are the things about Unacademy only. Then okay, let's look at the batches. So basically, this is about Samurai batch. So in from week 1 to 4, we will be telling you about the building blocks of programming, in which like we'll be telling like how programming actually works. Then from 5 to 8, we'll have an introduction to C++, and then we'll have searching, sorting. Then so basically, this is the things you can read, I hope. So this is the complete like for a complete 11 months, we have decided like what all things that we are going to be doing. As you can see, we are also going to be covering advanced topics like dynamic programming, computational geometry as well. Okay, then let's come on to the batch structure of interview batch. For this also similarly, we have from week 1 to 2, we have basic fundamentals, then we have maths and placement puzzles, and so on. These are some of the educators who will be going to teach you. As you can see, these are all like very highly qualified educators. And then coming on to the subscription. So as you all know, like these are the subscription prices. Obviously, the 12-month subscription is the best. And apart from that, you can also use my referral code, which is NBYT. And with this referral code, you'll get a 10% discount. Okay. All right. Cool. I hope there is no disturbance in my audio. Can someone tell if they're feeling any disturbance in the audio? Okay, anyways, let's move ahead. Let's go on to problems now. So, I am actually going to be solving first, second, third, fourth, fifth, sixth, and seventh. Now, the reason why I'm saying that this is the sixth problem of this because this is actually a little good problem. This requires a knowledge of number theory and everything. And don't be scared because of the number of submissions because, okay, let me tell you this. For some reason, in Dev 1, so King Killing had 50 submissions only, and increasing this subsequent question had 80 submissions in Dev 1. Now in Dev 3, we have 110 submissions for King 1 problem, and then for increasing sequence, we have 1519 submissions. And the reason is because many people have cheated in this one. There are many solutions available of this problem, and they've just copy pasted the code. So basically, this is something that requires knowledge of number theory as well. You need to know what Euler tangent is and things related to that. Also, you can do this by just like looking at the pattern and then applying the concept like using Euler tangent. But anyways, like I won't be solving this because I don't believe this is very much useful for the viewers of this channel. But yeah, except this and the last problem, we will be solving every other problem. Okay. All right. Cool. Also, if you are someone who also cheated in this contest, please don't do that. That's not a very good thing, and there's nothing to be proud of. This rating is like a number only. All right. Cool. Okay, so let's not waste much time and move ahead to the first problem. Okay. Actually, like the long problems are really nice. Otherwise, like a few problems really give you a very nice idea of DFS and everything. So I'm pretty sure this stream will be a learning from many people. Is there any plug checker? Yes, Athen, there is a plug checker that CodeChef runs, but yeah, there are many ways to like beat that plug checker. So I don't really think like even half of them will be caught this time. Yeah, but yeah, I'm sure like out of these 1500, at least 500 will get flagged. But yeah, apart from that, rest 1000 will be able to pass. Okay, cool. Okay, let's move on to the first problem, which is solubility. Now, the problem says that suppose for a unit rise in temperature, the solubility of sugar in water increases by B grams per ml. Okay, so we have for per unit rise. So for per unit rise, the solubility increases by B grams per 100 ml. Okay, cool. Now, chef does an experiment to check how much sugar he can dissolve given that he initially has 1 liter of water at X degrees. Okay, so he has 1 liter of water at X degrees. Okay, and the solubility of sugar at this temperature is A grams per 100 ml. So basically, at this time, the solubility is A grams per 100 ml. Okay, cool. Chef doesn't want to lose any water, so he cannot increase the temperature to at most 100 degrees. As we know, like at 100 degrees, the water would start to boil. So he cannot increase the temperature above 100. So this tells us that the total increase in temperature that we have to do is going to be 100 minus x. This is the total increase. Okay, cool. Now, also chef, okay, assuming no loss of water takes place during the process, find the maximum amount of sugar that can be dissolved in 1 liter of water. Okay, cool. Okay, now let's, okay, cool. So we know that we are given 1 liter of water only and we do not want to lose any amount of water. Now this 1 liter of water is actually at X degrees. That means that the amount of water that we need is 100 minus X. So the amount of degrees that we need more is 100 minus X. So the difference is 100 minus X. And we know that the solubility, okay, so this is the difference. Now if we multiply this by B, because we know that with per unit rise in temperature, the solubility increases by B. So basically, we need to increase the temperature by this amount. Therefore, we'll multiply this by B. Now, this will give us the grams per ml. The solubility that is increased in grams per ml per 100 ml. And we already know that this 1 liter water had a solubility of A grams per 100 ml. So this is the complete solubility in the final step. But now one thing to notice is that we are actually given 100 liters of water. Therefore, what we need to do is we actually need to multiply this complete value by 10. Reason is because we had this value for 100 ml and we need to make this for 1 liter. To do that, we just need to multiply this 10 times. So this is, so basically the final formula comes out to be, final formula is 100 minus x percent n times b plus a into 10. This is all that you need to do. Okay, then can you check submission for King Killer? Most of the submissions that didn't even remove the comments, will they get caught? Yes, then if they didn't remove the comment, that means they will surely get caught. And I myself didn't know that King Killer submission was also present somewhere online. Okay, this was my first long challenge. Seeing these type of submissions is really demoralizing. Then don't really like look at those submissions. Like people are cheating. That's like there is no point of doing that, and there is no increase in the like better thing in that. Okay, at what time will you solve div 2 problems? So I'm actually going to be solving every problem line wise except the increasing sequence and king killing. So yeah, like in 10 minutes, I think we'll be done with the first 3 problems. So yeah, I know div 2 actually had from the third problem only this time. So yeah, first problem is done. We'll move on to the second problem in like 2 minutes. Okay. Okay. So valid parts next. I'm actually going to go line wise. Okay. Okay. Let me just show you the solution of this one, the code of this. Okay. Okay, I have all the codes there. Yeah, okay. So this is the solution. So basically for every test case, I'm scanning X, A, and B, and then I'm just like using the same formula, which is 100 minus X times B plus A times 10. And we have to print the solution in every new line. So that's why slash. Okay. I hope this is clear to everyone. Can people tell me in the chat if they're clear with this approach? And then we'll move ahead to the next problem. Okay. Okay, long challenges are really fun. So I think the stream is going to be really like nice for people who are new to competitive programming. Okay, so the next problem is golf. Okay, I would also like to know from people in the chat how many problems they were able to do this time, because you had 10 days. So I believe like you were able to like give many tries to every single problem. So let's see who got how many problems. Okay, anyways, let's move on to golf. It's a lockdown. You're bored in your house and are playing golf in the hallway. The hallway was n plus 2 tiles numbered from 0 to n plus 1 from left to right. Okay. So basically, we had a hallway. Okay. Okay. Let's have it black on. Okay. This is 0, I believe, and this is n plus 1. These are all the tiles. This is 1, this is 2, and so on, and this is n. Okay. Rakesh says I got stuck after solving first problem. Okay, that no issues, Rakesh. I believe you will learn a lot in the stream then. Just stick to the stream and like see how we are solving. Vishal says 3. Saran says I can solve only one. So sad. No, Saran, it's not sad. It's okay. You must be new to programming. So like you can learn a lot from the stream and other streams. Okay. He says there are 6 problems except king killing. That's really nice, I think. Okay. Okay. Cool. So the problem says that we have n plus 2 tiles numbered from 0 to n plus 1 from left to right. There is a hole on a tile number x. Let's say this is tile x. Okay. Let's say this is tile x and there is a hole. Now you hit the ball starting on tile 0. When you hit the ball, it bounces at length k. The tiles covered by it are 0, k, 2k and so on until the ball passes the tile n plus 1. If the ball doesn't enter the hole in the first try, you try again, but this time standing on the tile n plus 1. Okay, so we first try from this point and then we try from this point. When you hit the ball, it bounces at length of k. The tiles covered by it are n plus 1, n plus 1 minus k, n plus 1 minus 2k and so on until the tile passes 0. Okay, so basically what we have here is that in every iteration, the ball bounces by k steps. So let's say k was 2. If k was 2, the ball would start from 0 and move ahead to 2. Then this would again jump off and go, let's say this is 4. And then it would again jump and go to 6. And so on. Similarly, when it starts from n plus 1, it is going to move, let's say this is n minus 1. So it again moved 2 steps. Then again it is going to move 2 steps. This is n minus 3. And then again it is going to move. So if you see, okay, let's see. So basically, so as you can see, this x is, let's say this x was 3. This x was 3. And let's say that n was, okay, let's say n was 6, 7, 8, 9. N was 9. Then this point was 9. This, sorry, n was 8. This point was 9. This was 8. And this was 7. Okay. Now, okay. So if you see, when we are actually moving from the start, we know that so when we move from the start, our movement is gonna be, we are at point 0, then we are going at 2, then we are going at 4, then 6, and then 8, which is actually similar to 0, k, 2k, 3k, 4k. And if you see, all these values are actually divisible by k. That means if this x is divisible by k, that means we will hit this position from the start. Now, if you see, this problem is actually very symmetrical in the opposite end as well. If we actually shift our origin from left to right, let's say this was 0, this becomes 1, this becomes 2, this becomes 3, then we have 4, 5 and 6. Okay. Now we know that if we actually started from this point, we'll move to 2, we'll move to 4, and then we'll move to 6, which is in logically point 3. So if the distance from the end is also divisible by 3 or by 2, and how to find the distance from the end? The distance from the end is actually going to be n plus 1 minus x, because as you can see, n plus 1 here was 9 and x was 3, so this gives us 6. And as you can see, this 6 is actually divisible by k equals to 2. Since it is divisible, therefore we can say that the ball will hit from the end. Therefore, the only two things that you have to do, you have to calculate distance from the start and you have to calculate the distance from the end. If any of these distance is a divisor of k, x, is divisible by x, that means the ball will hit. Okay, and that is all we had to do. So if I just show you, okay, let me just show you the examples as well. So let's rub this. Now, the first example, okay, let's look at the input. So the inputs are n, x, and k. So n is 5, that means n plus 1 is 6. Our x is 4. Now the starting distance is actually equal to x and the k is 2. We know that 4 is divisible by 2, that means this point will be hit from the starting only, and hence we have a yes. Let's go to the next one. In the next example, we have n equal to 5, that means n plus 1 is going to be 6. X is 3, that means the starting distance is 3 and k is 2. Now this x, which is 3, is not divisible by 2, therefore we know that the point will not be hit from the starting. Now let's see if this is hit from the end. Now the ending distance is n plus 1 minus x, which is actually 6 minus 3. 6 minus 3 is again 3, which is not divisible by 2. Since it is not divisible, therefore we can say that the point will not be hit from the end as well. And similarly, we have to do the same thing for the third test case. So let me just quickly show you the code. Okay, so if you look at the code, that is exactly what we are doing. So this is the starting distance, which is x only, and then the ending distance is n plus 1 minus x. So what I'm doing, after scanning the input, I'm just checking if the starting distance or the ending distance is divisible by k. If they are divisible, then we print a yes, otherwise we print no. Okay, I hope this is also clear to everyone. If yes, we can move ahead to the next problem. Okay, the next problem is Zorb equality. Okay, let me run this. Okay, if anyone still has any doubt, they can let me know in the chat. Okay, Hitayen says, can you give any idea about king killing? Okay, in the end, I'll give you an idea like how to do that. Okay, Rakesh says yes. Okay, perfect. Let's move on to the next problem then. Now, in the next problem, for a given n, find the number of ways to choose an integer x from the range. Okay, so the range is 0 to 2 to the power n minus 1 inclusive. Okay, such that now we are given that x XOR x plus 1 should be equal to x plus 2 XOR x plus 3. Okay, where this denotes the XOR. Okay, now since the number of valid x can be large, output it modulo 10 to the power 9 plus 7. So basically the problem says that we have to find the number of valid pairs in this for x such that this condition is true. So let's say n is what? Let's look at the test cases and let's say n is 2. Let's start for x is equals to 0. Now if x is equals to 0, that means, sorry, x cannot be 0 if x is 1. Okay, now, and this is not x actually, this is n. Okay, if n is 1, then let's say for, okay, for x equal to 1. Now if x is equal to 1, then x plus 1 is actually going to be, so let's write this in bit. this is 2, x plus 2 will be 3, and x plus 4 will be 4. Now 1 in bit is actually 0, 1, 2 in bits is 1, 0, 3 is 1, 1, and 4 is 1, 0, 0. So let's add one more zeros. Now let's find the XOR of these two values. The XOR of these two values is actually going to be 0, 1, 1. The XOR of these two values is going to be 1, 1, and 1. Since you can see that both these values are not equal, that means for x equals to 1, this condition does not satisfy. Okay. Now let's move on to x equal to 2. Let's go for x equal to 2. If x is equal to 2, then x plus 1 will be 3, x plus 2 will be 4, and x plus 3 will be 5. Now this is actually 0, 1, 0, this is 0, 1, 1, this is 1, 0, 0, and this is 1, 0, 1. Now the XOR of these two values is 0, 0, 1, and the XOR of these two values is also 0, 0, 1. Since both these values are equal, that means we can say that for x equals to 2, this condition satisfies. So let's say, write it here, for x equal to 2, this condition is satisfied. Now let's move ahead, or let's stop right here and let's see like what is happening. We know that, let's say this is some random number, okay, and these are the bits, okay. Now we know that whenever we add plus 1 to this number, this plus 1 actually changes the first bit. If it is a 0, it becomes 1. If it is a 1, it becomes 0. Okay. If we do plus 2, the second last bit changes. Basically, if we do a plus 1, this first bit changes. If we do a plus 2, this second bit changes. If it is a 0, it becomes 1. If it is a 1, it becomes 0. Okay. Now, oh, sorry. Similarly, if we have a number and if we actually do a plus 3, if we do a plus 3, then the last two bit changes. That is, if both these are 0, 0, then these become 1, 1. If these are 0, 1, then these become 0, 0. Then, so basically if this is 0, 1, it actually becomes 1, 0, 0. But since we are only talking about the last two bits, therefore this becomes 0, 0. If it is 1, 0, then 2 plus it becomes 0, 1. And if it is what 1, 1, then it becomes 1, 0. Okay. Now as you can see, when we are actually doing plus 1, plus 2, plus 3, we are only playing with the last two bits. Basically, when we add plus 1, plus 2 or plus 3, only the last two bits change. And with that, we can say that if we are able to find out the answer for the first two bits, the rest of the bits are actually, even if, so basically, if we know what we need to fix in the first two bits, then all the previous bits will remain same. So let's say, so basically what does this mean? This actually means that we had in total n bits. Because for example, let's say if n is 1, if n is 1, then this value actually becomes from 0 to 1, and there is only one bit to write this. If n is 2, then this actually becomes 0 to 3, and to write numbers from 0 to 3, we only need to write numbers from 0 to 3, we only need 2 bits. Okay. Similarly, for n equals to 3 also, we need 3 bits. So basically, this is just a way of telling telling us that we have n bits in total. Okay. So, okay. Now, we know that, let me just rub this. Okay. Now, we know that we have n number of bits. Okay, let's say this is n. Then this is actually going to be n minus 2. Okay. Now we know that for these two bits, we need to find the answer. Like how many values are there for these two bits which actually remain the same after the changes as well. These bits we know are going to remain the same even after changing the values. Therefore, how many options do we have for every bit? For this bit we have two options, that this can be either 0 or either 1. Similarly, for this bit as well, this bit can be either 0 or 1. So this also has two options, and so on. Will have, for every option will have 2. Therefore, this will actually become 2 to the power n minus 2. Now we are only left with the first two bits. So let's see how many values are there. So in the first two bits, we can either fix 0, 1, 2, or 3. Okay. We already saw that for x equals to 2, we get same values. If you later see for x equals to 0 as well, because let's say x is 0. If x is 0, that means the x plus 1 is actually 0, 1, x plus 2 is 1, 0, x plus 3 is 1, 1. Okay. Now this actually gives us 0, 1, XOR of this. This XOR of this gives us again 0, 1. So with this we can tell that for 0 and for 2 we get same values. Okay. Now with this we can say that these two indexes are actually going to give us two values only. And we know that the previous indexes gave us 2 to the power n minus 2. Therefore, the final answer is actually going to be 2 times 2 to the power n minus 2, which is 2 to the power n minus 1. So all we have to do is, we're given an n, we just need to return 2 to the power n minus 1, and that is the complete answer. Okay, so I hope this is clear. This question was a little tricky. There were a few things to look. Let me show you the code. Now, there is one thing that you need to see. You're actually given 10 to the power 5 test cases. So for every test case, you cannot run a loop and find the value of 2 to the power n minus 1. Okay, so what you need to do is, you need to, now we also know that the maximum value of n is 10 to the power 5. So what we can do is, before scanning all the test cases, we can actually pre-compute all the values of 2 to the power n and store it in an array. And then whenever we scan a value for every test case, we can just print those values. So let me show. Okay. So we have an array of 1e5, which is 10 to the power 5. And for every value, we are pre-computing all the values. We've pre-computed, we have find the mod as well. And then for every test case, I'm just returning 2 to the power n minus 2. And that's it. Okay. I hope this is clear to everyone. Okay. Raghav says, my father also, please tell. We used to show laptop screen and whiteboard together. Raghav, I'm actually using multiple softwares. You can, okay, I'll just write the names. It is OBS for the screen, and then the other one is IRM. Okay, I'm not gonna explain everything. You can just like Google them and you'll like understand like how to do this. Okay, okay, cool. Let me just rub this and let's move on to the next problem. All right. Okay, the next problem is tic-tac-toe. Okay. Tic-tac-toe is a game played by two players on a 3x3 grid. In a turn, a player chooses an empty cell and places the symbols on the cell. The players take alternative turns where the player with the first turn uses the symbol X and the other players use the symbol O. The game continues until there is, okay, this is the standard definition of a tic-tac-toe. Okay. You're given a tic-tac-toe board A after a certain number of moves consisting of symbols O and X and underscore. Then underscore signifies an empty cell. Okay. Now print 1 if the position is reachable and the game has drawn or one of the players won. If the position is reachable and the game will continue for at least one more move, if the position, so we have to print 2, or we have to print 3 if the position is not reachable. Okay. So basically, let's look at the test cases. Okay. So let's look at the first test case. Okay. So in the first test case, we have X, 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 and for O, we have O, O, and O. Okay. All right. Now, is this state possible? The first thing is that we need to check. Let's see. So let's make another board, and let's say the first. Now we know that the first player starts with an x. So let's say the first player started with this x. Then the next player must have drawn this 0. Then we had this x, and then we had we had this 0, and then we had this x. We had this 0, and then we had this x. So as you can see, this state is actually reachable. Also, one more thing that we were able to notice is that for a game to be reachable, number of x is actually going to be either equal to number of O's, or it is going to be equal to number of O's plus 1, because there is a possibility that we did not put this x, okay, and the count of both the values was 3 and 3, but since x was playing first, therefore x might have taken another chance and he might have made a move. But there is no way that number of x's is actually number of O's plus 2, because for that we will have to make another x, which is not allowed. Okay, so this condition is clear that number of x should be either equal to 0, or number of x should be either equal to number of zeros plus 1. Okay, let me just write this a little above. So number of x should be either equal to number of O, or it should be equal to number of O plus 1. Okay, okay, cool. Then, okay, let's move ahead. Let's look at the next test case. If we look at the next test case, we see that we have a board, and in this board, we had 3 zeros and 3 crosses. Now, from the count of x and 0, we can say that this is valid. But if you see, this is also a win for x, and this is also a win for O. And it is never possible for both the players to win. Okay, therefore, we need to ensure that only one player wins. One player wins. Okay, cool. So we know about these two conditions. Okay, all right. Now there are a few more conditions. Okay, so basically let's try to write. So basically we'll first see that number of x's is equal to number of O's plus 1. Okay, so the very first condition that we need to check is going to be this, which is number of x is equals to number of O's, or it should be equal to number of O's plus 1. Okay, cool. After this, if this is possible, then it's okay. If this is not possible, then we can just print 3, because we know that this is not a valid state. Now let's say this was true, then we need to check. That means this position is reachable. We know that we are able to reach this position. Okay, now we need to see if any one player has won or not. Okay, because we know that only one player can win. So we'll first check for x. So we'll say that let's check for x, check x win, and check O win. We'll check if either x has won or O has won. Okay, cool. If x is won, if both of them won, if both win, if both have won, that means this is not reachable. Okay, so we print 2 or print 3. Okay, if this is not the case, then we have 3 options: either x won, or O won, or nobody won. Okay, let's write nobody won. Okay, if x won, now we need to check if, so basically if you look at print 2 and 3, for 2 we just need to check that if it is reachable and the game will continue for at least one move, and in 1 it is said that it should have either been won or drawn. Okay, so there is one condition that number of, okay, let me just write x and O, that number of x plus O is 9. Sorry, If x won, then we can just say that we can just print 1 because the position is reachable and the game, one of the players won. Similarly, for this case also, we can just write 1. Okay. Now, but if nobody won, then we need to check maybe this is a draw or maybe we still can move. Okay. So, in order to do that, if x plus o, the count of x plus o is 9. The reason why I'm saying 9 is because if you look at the board, there are 9 places 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So, if all the places are filled, that means this is the draw, we print 2 because this position was reachable but the game cannot be played anymore. Okay, else we print 1 because now we know that nobody won, but still any player can move because nobody has won and the game is not a draw by now. Okay, so these are the reason why I wrote all the cases, because it is an implementation problem, as you can see. Therefore I just wrote all the options cases. Now we just need to code everything up. Okay, so to do that I'll just show you my code and you can just follow along. Okay, let me just show my code. Okay, this is my code. Let's look at this. So in this board I'm actually scanning all the values. Okay, and then in count x I'm counting all the values of x, and in count o I'm counting all the values of o. Okay, now the very first condition that we had to check, was that the count of x should either be equal to o or 1 greater. Okay, so that is exactly what I've written. The count is equal to or it is 1 greater. Okay, then the next thing that we need to do is we need to check for winning of x and win of o. Let's just assume this is one function. Let's get into this function later. Let's see. So basically, if x won, this win x will be 1. Otherwise, it will be 0. And similarly for this o also. Now, if both of these won, then we just print 3. Okay. Then the next thing is, okay. Okay. If x won, then we are printing 1 or we are printing 3. Okay. So the reason for this is because, okay, there is no need of this actually. Okay, I'll just remove this. There is no need of this and there is no need of this. Okay. Okay, yeah, there is actually a need. So basically, now if x won, that means the number of count of x should be 1 greater than o. Reason is because, let's see, if this was this, and let's say x had to win. So we made these here and o are here and here. Okay. Now the count of x needs to be 1 greater than o because we are moving x first, and if x won, we need to stop the game at that point only. Therefore, we'll always be one move ahead of x for x whenever we win for x. Okay, that's why we are checking the count. If the count is 1 greater for x than o, then we print 1. Otherwise, we say that this position is not reachable. And similarly for o. Now o is actually moving in the second place. Okay, so whenever he makes the second turn, the count balances. Count of o becomes equal to count of x's. Okay, so if the count is same, then we print 1, otherwise we print 3. Then in the last case is this one, when nobody won. If nobody won, then we just check if the count is equals to 9, that means it's a draw. Otherwise we print 2 because we can still move. And then in the cells I have 3 if the count of 0 and x do not match. Okay, then this is left check function. So let me just show that to you. There are many ways to implement this. This is how I implement it. So basically, in this for loop, I'm checking all the horizontal lines and the vertical lines. So at this place, I'm checking, I think, all the vertical lines. Okay, so I0, I1, I2. Okay, so you can just, this is a very standard function. Okay, so you can just look at it what I've written. So in this, I'm checking all the vertical lines, and this I'm checking all the horizontal lines, and then I'm checking, this is one diagonal, and then this is the other diagonal. Okay, so okay, so this is the code. You can look at this code later. I'll just share all my code somewhere. Okay, so I hope everybody got this. If yes, we can move on to the next problem. This problem didn't really had much to do. We just had to think of all the cases and implement it. So this was a good implementation problem, I would say. Okay, let's move on to modular equation. Okay, or before modular equation, let's move on to treehouse. This is a good problem, I would say. Okay, and I'm actually going in the order of what the problems are in Div 1. Okay, so that we actually know the difficulty of every problem. Okay, because these solutions are just because, like, I know for this problem also many people cheated. Okay, so let's not look at the order of these problems. Let's look at the order in Div 1. Okay, cool. Let me just rub. In the meanwhile, can people tell if they're able to understand this tic-tac-toe problem? Okay, okay, okay. Let's look at the next problem now, which is treehouse. Okay. This is a large treehouse in an unknown world. It is ruled by a great emperor KZS. It consists of n nodes numbered from 1 to n in which the people of that world reside. The nodes are ordered in a tree structure rooted at node 1. You need to assign values to the nodes according to the wishes of the emperor KZS, which are as follows. The value of node 1 to 1 is x. Okay. All immediate children of any node have pairwise distinct values. For every node with at least one immediate child, the GCD of the values of all immediate child is equal to the value of the node. The total sum of the values of all nodes should be minimum. The greatest common divisor GCD of two values, okay, this is the definition of GCD. Print the sum of all values modulo 10 to the power 9 plus 7. Okay. Saran says modular equation. I'll tell about the modular equation after this problem. Okay. After treehouse, I'll solve modular equation. Okay. Pawan says, I don't even understand the problem tree houses. Okay, I'll explain the problem first. Okay, so what the problem says is that we are actually given a tree. Let's say this is the tree. This is 1, this is 2, this is 3, this is 4, and this is 5. Okay, what they're saying is we are given a value x. This is the value of this node. Now, let's look at the cases. So basically the value of node 1 is x. For node 1 we have given the value 1, x. Okay. All immediate children of any node have pairwise distinct values. Okay. So basically the value at this, let's say this is a, and the value at this place is b. A should not be equal to b. And let's say the value of this place is c and this is d. And c should not be equal to d. This is what they mean. Okay. Yeah, but when I'm explaining it briefly, okay. So for every node with at least one immediate child, the GCD of values of all immediate children is equal to value of the node. So basically, okay, let's make one more node here for some clarity. Let's say this was 6. So, and let's say this was E. So C should not be equal to D, and this should also be not equal to E. So basically, every value of C, D, and E should be different. Okay. Now, the next is for every node with at least one immediate child, the GCD of the values of all immediate children is equal to value of node. So what they mean by that is GCD of A and B should be equal to X. Reason is we are given that for for this particular reason, okay, the GCD of the values of all immediate children is equal to the value of the node. We know that the value of first node is X, which is fixed. So GCD of A and B should be X. Then let's come on to these. These tell that GCD of C, D, and E should be B because the GCD of the parent of all these three children is B. Okay, okay. Then print the sum of all values, print modulo 7. Okay, good. Now the last condition is that total sum of the values of all nodes should be minimum. Okay, so basically the sum, which is x, which was the root value, plus a plus b plus c plus d plus e should be minimum. Okay, let's rub all this and let's take an example. Okay, let's see. Okay, okay, for now let's remove this. Okay, there are a few things to observe now. Let's say that the root had a value of 1 only. Now, if the root had a value, okay, let's first consider a binary tree only. Let's say this is the tree. Okay, this is 1, this is 2, and this is 3. Now, we are given that the value at the root is 1. Okay, now, okay. Now, what are the minimum values for 2 and 3, which will give us a GCD of 1? Now, since this is 1, we can have like any values. We can have 4, 5 here, we can have 3, 4, we can have 1, 2, or anything. Let's see. If we have 4, 5, the sum will be 1 plus 4 plus 5. For 3, 4, the sum will be 1 plus 3 plus 4. For 1 and 2, the sum will be 1 plus 1 plus 2. As you can see, this sum is minimum. We took 1 because all the values have to be greater than 1, because we have to find the GCD. Okay, and this one is actually similar, equal to the value at the node. So we know that we cannot take anything smaller than this. Okay, and we took 2 next because, okay, so we took 2 next because this gives the minimum. Let's say that this was some x value now. What should we do? We know that this node will also take x. Now, what is the minimum value for this 3, which will again give a GCD of x? That value is actually should be a multiplier of x only. Okay. Now, we cannot take x here because every value has to be pairwise distinct for the children. Therefore, we write 2x. We could have also written 3x here, but since we need to find the minimum sum, we write 2x here. Now, we know that for this tree, this is the answer, x, x, 2x. We also know that this x can be generalized. Basically, if this root had a value of 1, then we could have just said this took a value of 1, this took a value of 2, and 1 plus 1 plus 2 is actually 4. Now, if this was x, this had a value of x, this had a value of x, and this also had a value of 2x. X plus 2x is all actually equal to 4x. So, if you see, this sum is nothing but multiplied by x. So, we can in the starting assume that root has a value of 1, and then we can, the complete sum, we can just multiply the complete sum by x. Okay. Now, what happens when we introduce one more node? If we introduce one more node, this value will take 3x. And similarly, if I have fourth node, this will take 4x. So, in this incrementing pattern, every value will be placed. Okay. Let's look at the above example again now. Okay. Okay, Rishabh, the link is not visible, I think. Okay, cool. Let's look at this example. Now, we know that the root has a value of 1 for now. Now, there are two options. We can either give 1 to this place, or we can give 1 to this place. Okay. Or we can give 1 to this place. Let's first see what happens when we give 1 to this place and 2 to this place. If we give 2 to this place, then this children, either one of these children will have a value of 2 and the other will have a value of 4. Now, why 4? Because the other value has to be a direct multiplier of this. Okay. Let's find the count. The count is 1 plus 1 plus 2 plus 2 plus 4. This actually makes what? 10. Let's see what happens in the other case. What if, okay, let's keep these values. This is 2 and 4. In the other case, this again has a value of 1. We fix 2 here and 1 here. If this has a value of 1 here, then we can say 4 has a value of 1 and 5 has a value of 2. Okay. Let's find the sum. Now the sum becomes 1 plus 2 plus 1 plus 1 plus 2. And this is, the sum is 7. Okay. I believe the link is not, okay. So what I'll do is after the stream, I'll just put the link in the comments. So everyone can go to the comments and they can use that link. Okay. So I'll just put the link after the stream in the comments. Okay, cool. Okay, so as you can see, this 7 is smaller. Okay. Now, since this value is smaller, we can say that we need to take the other case. So let's remove this. From this, there is one thing that we get. Now, let's look at the reason, like why this is happening. So basically, if we had 1 here, then the total sum was 1 plus 1 plus 2. If we had a 2 here, then the values were 2, 2 and 4. So basically 2 plus 2 plus 4. This sum is 4 and this sum is 8. So basically this is nothing but multiplied by the root value. Therefore, we need to ensure that every root value is the smallest possible. Okay, so okay, cool. So let's do one thing. Now we know that the value at the root depends upon number of children it has, because basically this had two children, therefore we had a value of 2 here. If this had, like, let's say 3 children, or let's say this had 4 children, then we had to like decide, we had to take 1, 2 or 3. Either one value will go to 2, the other will go to 3, and the last value will go to this. So we need to see how many children every node has. This children has 0 children, this child has 2 more children, and this child has 4 children. Since these are in this pattern, we'll place 1 here because we know that this 1 is actually going to impact these children as well. Therefore, we need to ensure that this node gets the smallest value. Okay. Then we'll give 2 to this place and 3 to this place. So this is the complete logic. What we need to do is we need to start from 1. We need to build everything, and so basically, okay, I'll just show. Let me make another tree which has many values. So let's say we have a root, then this is 2, this is 3, this is 4, this is 5, this is 6, and let's say this is 7, 8 and 9. Okay. Now we know that this child has the maximum number of nodes. So let's start. Okay. So we know that we'll give 1, 2 and 3. We'll give any random values to these values. Okay. Now since this is 1, this is 2 and this is 3, we can say that this 4 has 3 children. And the value, let's say the value here remains 1. So with this, what we can say is actually, okay, this has 1 value, right, for now. Now let's come on to this 5. This 5 has only 1 children. So this has 1 children only. Now let's count for this 3. This has 2 children. And this 2 has 0 children. So whenever we are placing values, we'll see that we place 1 here. Now we know that this 3 has 2 children and this 2 has 0 children. Therefore, the smaller value will go to 3. So we place 1 at this 3. After this 1, we place 2 here. Now in this children, we know that 4 has 3 children and 5 has 1 children only. So we are going to place the smaller value for 4. And for 5, we'll have 2. Now when we, okay, so this again gets 1. And then for this 9, now these 3 can be any random value. So we place 1, 2 and 3. And for this 6, we are actually going to place 2. Because the minimum value right now is 2. Okay. Then, okay, so this is the complete logic. Let's find the sum. So the sum actually gives us 1 plus 2 plus 1 plus 2 plus 1 plus 2 plus 3 plus 2. And the sum is 4, 6, 7, 8, 9, 10, 14. So how to like find the values? For that, let me just open up the code and I'll show like how to do this using a DFS. Okay. Okay, let's look at the code. What the name of this problem is? Valid path, I think. No, it's tree houses. Okay. So this is what's happening. So basically, what we are doing is we are actually running a DFS. Okay, let me just run these values, remove these values. Okay, so as we know that DFS actually takes everything to the leaf values. So when we have leaf values, we know that this is going to get 1 value, this is going to get 1 value, sorry, this is going to get 2 values, this is going to get 3 values. And with this, we know that this 4 will actually have a 1 value. So let's write the sum of these. The sum of these is actually going to be 7. Okay. So with this, we know that this 4 is actually going to have a cost of 7. Okay. Then we know that this 6 is actually going to get a value of 1. And the sum of, okay, let's write the count of children only. So this has 6 and this has 1 for now. Now let's come on to this 3. Now what this 3 is actually going to do is, this 3 knows that this 4 has more children than this 5. How it knows is because we know that this 6 is greater than 1. Okay. What we'll do is we'll actually start multiplying all the values. So we'll multiply the very largest value by 1. We'll multiply this value by 2. And similarly, if we had any other value as well, we would have multiplied it by 3. So basically, this one actually converts to 2. So this 3 gets 8. And this 2 has 1 only. Now what we do, okay, so what, okay, I think there is some issue. Okay, this is not there. Okay. Okay, yeah, cool. I think I did some error in this counting. So let's remove this. Okay. Okay. Now this one comes and this one says that I'll give the smaller value to the bigger one. So this is 8. We'll just multiply this one by 2. And this count now becomes 10. And this, now we just multiply this 10 by x. And this is the answer. So I hope like you are able to get this, like how we are running it into the DFS. So if you're not able to understand this, okay, let me show you another code which is also fine. I think that will be easier for everyone. Let me just open up that code. Okay, let's look at this code. No, this is not the one. Oh, just a second. Yeah, this is the one. Okay, let's look at this code. Okay, so basically what I'm doing is I'm actually running a DFS first. I'm running a DFS first. I'm actually counting the count of all the children of every node. So if you see, I'm doing nothing but I have a array of child, and in this I'm just like returning the count of every node. So basically, let's keep this 1, 2, 3 only. So basically this 7 will say I have 0 children, this 8 will say I have 0 children, this 9 will say I have 0 children, this 1 will say I have 0 children, this 4 will say I have 3 children, this 2 will say I have 1 child, this 3 will say I have 6 children, and this 2 will say I have 0 child, and this 1 will say I have what, 8 child. Okay, now what we do is we actually start from x. I actually run a DFS from 1 and send the value as x. So what happens is, let's see what is happening. So basically in this vector, I'm actually going to get all the values of all its children. Okay, so basically this vector for 1 is going to give me 6, 0. And for every value, I'm also like having the value of its node as well. So this is for 3 and this is for 2. The next thing that I do is I sort this in terms of decreasing. So basically I first sort it and then reverse it. So basically the highest value will come first. So we have, this is the same order. Okay. Now what I do, I actually have a current value which is nothing but GCD. GCD is my x right now. So basically to 3 I assign a value of x. As you can see, current value is GCD into I plus 1. I right now is 0. So for this becomes GCD only. Then for I equals to 1, which is this node, which is 2 actually, I see that current value is going to be equal to GCD into 1 plus 1, which is 2. So basically I give 2x value to this. And then I call DFS for this node and this node. Let's go for this node. Now when we run this node, in this vector, I'm just scanning all its children again now. For every child, I store the value of its children. So basically what I get is, I get 1, 5 and 3, 4. These are the node numbers and these are the child numbers. Okay. Then I sort these values. So if I sort these, this will come afterwards. So 1 and 5. Now I say that the first value will get, okay, if you see, I pass GCDs also as equal to current values now. So basically this will have a GCD of x only. So what I do is, assign x to first value and 2x to the next value. I assign x here, sorry, x here and 2x here. And similarly, when I call for these as well, okay, this is 8. I send x, so therefore this gives x, 2x and 3x. So you can just look at this code as well if you want. But this is a little bigger code, so I wrote another code. Okay, this is like the simplified version of this code. Okay, yeah, this is the simplified version of this code. So you can look at any of the codes, and I hope this problem is also clear to everybody. Okay. Okay, cool. Let's move to the next problem now, which is modular equation, another good question. So basically this problem was nothing other than like DFS. It was a you need to know about the basics of DFS, how DFS runs, and then you would be able to do this. Okay. Okay. I did the same question with same approach but by BFS. It is showing wrong answer on test case 1 and 2. Raghav, the reason for that is actually because you need to have a count of all the values below, not just in BFS. You are actually having the values of the current level only. You need to have the values of everything before that. That is why like I recommend you this code. That is why like DFS is good in this. Like I am able to understand the issue that you are getting. So like follow this code. Okay. 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 Cool. Let's move to the next problem now. What is the next problem? Okay, the next problem is modular equation. Yeah, we have modular equation and then we'll have bounded paths. Okay, cool. Okay, so this is actually a pretty simple problem, I would say, but yeah, this requires a little bit in-depth knowledge. Okay, let's look at this problem. So basically, the problem says that given integer n and m, find the number of ordered pairs a and b such that, okay, let me write everything. So we have m mod a mod b. This should be equal to m mod b, m mod b mod a. Okay, and we are also given that 1 is less than equal to a, less than b, less than equal to n. Now if you see, we know that a is smaller than this b. Therefore, whatever this value is going to give us will remain same after the mod of b as well. Because let's say this is 5, this is 7. If we take any value here, this will return us a value which will be less than 5. And any value less than 5 will have a mod same with by 7 as well. So therefore, there is no need, if you see, there is no need of this mod b. So basically, what this equation comes down to be is m mod a should be equal to m mod b mod a. Let's do one thing. Let's remove this equal to and take it on the other side, and let's say this is 0. Now we have mod a here, mod a here. So let's say this is m minus m mod b mod a should be equal to 0. Okay, so let me rub everything and write this on the top, and then I'll explain like what do we need to do with this. So for now we have got the condition as m minus m mod b mod a equals to 0. Okay, so let's rub this now. Now let's try to analyze this condition. What does this tell us? This tells us that whatever this value is, it should be divisible by a. Divisible by a. Okay. With this, what do we get is, let's find the value of m mod a. Let's say this was y. Okay. If this was y, in order to have this complete value divisible by a, we can say that this value should be equal to y, right? Because as you can see, like if this will be equal to y, then this will become, if we try to write this, so basically m will become some x times a plus y. So when you take mod with a, this gives us y. Okay, so basically when you like subtract, write this here, xa plus y minus, now you need to minus something such that this complete value becomes mod a. Okay, and to do that, this should be equal to y. So basically m mod b should be equal to y, because if this is equal to y, this y will cancel out with this and this will become x times a, and percentage of this a will be 0. So basically what do we get here? We get that if m percentage a is y, then m percentage b should also be equal to y. Okay, we also know that a should be less than b. So how do we calculate this? To do this, we can just run a for loop from int, let's say I equals to 1 till I less than equal to n I plus plus. Okay, there's a reason why I'm writing this code. I'll show, like tell you why I'm writing this. Okay, so let's say, let's have a map. Okay, let's say, okay, we know that a should be less than b. Let's have a map. Let's have a map of what? Int comma int, and let's say this is count. Okay, now let's find the value of I mod b. Okay, let's find the value of, sorry, m mod I, because we are assuming that this I is b. Let's say that int x is equals to m mod I, because right now we are assuming that this I is actually a b. Okay, I think this is not visible. Right now we are assuming that every I is b. Okay, and now we just say that count of x plus plus. Okay, but let's say this I reaches to some point. Now we know that whatever this value, okay, let's say this is count of x plus plus, whatever be this value of x right now, we know that, so basically this is b. Okay, so we know that every value smaller than I, okay, every value smaller than I which gave us the same x after modulo is actually can be a potential a. Let's say this was let's say x was 2 here and I was, let's say, 7, and let's say we got the same 2 with, okay, let me just take an example. Okay, let's say that m was what, 7, and let's say for now this I has reached to 8, no, not 8, has reached to 6. Okay, now we know that we need to calculate m percentage I, which is m percentage I is actually going to be 1 right now. So basically our x right now is 1. Let's say we say that this I is b. If this I is b, we need to check every value from 1 to b which gave us the same remainder. So we know that if we actually find modulus of 7 with 1 or modulus of 7 with 3, yeah, these are the 2 or 2, sorry, 1, 2 or 3, all these 3 values give us 1 when taken a modulo by 7. So we can say that for this 6 we'll have 3 pairs. One pair will be 1 6, the other pair will be 2 6, and the last pair will be 3 6. So basically what we can do here is, whenever we get this mod value, we can just say that answer plus equals to count of x, because this x, this count right now has all the values in this x which were less than this I and gave the same remainder. So basically in this count I'll get all the previous values. So, and with this, I'll get every value which had the same. Basically, I'll get all the pairs of A and B which gave the same remainder. Now, there is still one thing missing. Okay, let me try to explain that now. So, what I'll do is, okay, so I hope everybody, okay, let me just open up the code and like I'll remove the other thing. Okay, cool. And let's say here I had plus this. So this is the code that I told you about right now. Okay, let's look at something. Now we know that, okay, we know that m minus y percentage a is equals to 0. And right here we know that this y is nothing but m percentage b. Okay, now there is a possibility. What possibility? Okay, so that we know that this m is of the form x times a plus y. Now, why are we only considering this y? Maybe this y is actually x plus y. Maybe this y is 2x plus y. Because if we consider this and this, if we subtract these values, this still gives us a minus 1 times, sorry, x, yeah. This still gives us a minus 1 time. Okay, just a second. So basically this is, sorry, this is a. Okay, this still gives us x minus 1 times a. This still gives us x minus 2 times a, right? So, and we can have 3a plus y as well, and this will give us x minus 3 times a. So basically, we were just calculating for this y, but we also need to calculate this for every value of a. So basically, because even if this is a, this y can actually be a plus y also, or it can be 2a plus y, or it can be 3a plus y. So we need to take all these values into account. Now, we know that this y is actually m percentage a. Okay, so basically, all we need to do is whenever we are finding this mod, we need to find, calculate, like we need to find this, we need to store this for y plus a, y plus 2a, y plus 3a, and so on till the end. So that for every I, we get all the pairs. Okay, so that is exactly what we need to add. So if we will just remove this and we'll have this value. So basically, this value is our y here. Okay, so what I'm doing is, I'm actually, my answer is pretty sure. I know that every value which is smaller than this particular b is in the count. Okay, so I'll just add that into the count, and then what I'm going to do is I'm going to increment every value of count which is of the form either y plus a, y plus 2a, or y plus 3. Okay, here I've actually considered this as b. You can have it as any variable, you can take any variable. Okay, so I hope this is clear. There are a few, like maybe this will take a little time to sink in. So just spend some time with the code, rewatch this video, rewatch why, like first understand like why we took only y, and then understand why we took the other cases as well. Why there was a need that we had to consider all the other cases, and then how we considered them. Okay, so yeah, this is pretty much it about this problem. It's okay if you are not able to understand 100% of it. Just spend some time in this, you will be able to understand it. Okay, and don't go at the number of submissions. Okay, like many people cheated, so just don't even look at the number of submissions. Okay, this was a good question, I would say. Okay, all right, let's move on to the last problem that we are going to discuss today, which is valid paths. Okay, this is a very nice problem, like a nice problem with a very simple method. Okay, okay, let's remove everything. Okay, I think okay, cool. Okay, so we have done 6 problems till now. Can people tell me in the chat like 6 or 7? We have done 4, 5, and 6. Yeah, we have done 6 problems. Can people tell me like if they're able to understand everything or not? Like Out of 6, how many they were able to understand completely? I hope all of them. And if yes, all of them, please like the video so that I know like you are liking everything that I'm teaching here. Okay. So just like the video, subscribe to the channel if you're not subscribed, and let me know in the comments or somewhere like you are enjoying these videos and like these are helping you. Okay. All right. Let's move on to the next problem, which is valid paths, which is going to be the last problem for this stream. Okay. So the problem says that you're given a tree with n nodes numbered from 1 to n. A set of n nodes is called valid if there exist two integers u and v, such that every node in S lies on a simple path from u to v. So what they're saying is, let me make the very first example. Let me make this one. So we have 1, then we have 1 attached to 2, then we have 2 attached to 3, and then we have 2 attached to 4. So what they are saying is, a simple path is nothing but any path taken in this graph or tree, whatever we call it, and just taking any. Now they're also saying that we can take nodes randomly. Okay, so basically let's consider this simple path. And this simple path, there are many like possible ways. So we have 1, we have 1 and 2, we have 1 and 3, we have 2 and 3, we have 1, 2, 3, okay, and we have 2 and 3 as well alone. Okay, so this is a simple path, and these are all the pairs that are possible from this simple path. Let's see what are the total number of nodes in this. Okay, so basically, okay, so total, as you can see, for this particular one, we have 13 total pairs. Okay, so 13 total, what do we call them? A sequence or what? A set. Okay, we have 13 sets. Okay, the first set is 1, second is 2, third is 3, then the fourth is 4, fifth set is 1, 2, which is this one and this 2. So basically this can be simple path, or this can be a simple path, or this can be a simple path. So there are many simple paths in which this 1 and 2 are coming. Okay, then we have 1 and 3. Now 1 and 3 can only be in one simple path only, which is this one. Then we have 1 and 4. Again, this can be in one simple path, which is this one. Then we have 2, 3. Now 2, 3 can be this simple path, or this simple path as well. Okay, and similarly, so we have all these sets. We need to find the total number of sets. Okay, all right, let's see this. Okay, let's see. Let's say I had only one node. How many simple paths can I, like how many sets can I make? Answer is only one. Okay, let's say, what if I had two nodes like this? What are the total number of paths that I could make from this? The total number of paths that I could make from this are 1, 2 and 1, 3. Sorry, 1, 2. And this gives us a count of 3. Okay, now let's look at this. Let's say this is 1, this is 2, and this is 3. Now, what are the total number of paths that we can find in this? Total number of sets. Okay, we have 1, we have 2, we have 3. Okay, we have 1, 2, sorry, we have 1, 2, we have 1, 3, we have 2, 3, and we have 1, 2, and 3. Okay, so in total we have 6, right? Let's look at this one. How did we get all these 6 paths? Let's look at this node. So we know that this node can only give us one path, which is 2. This node can only give us one path, which is 3. Now let's look at this root as well. When this node is combined with this root, we can say that one simple path is this alone, and one simple path would be 1 with this. So basically 1 with this 2. Okay. Similarly for this, we can say that one simple path will be this alone 3, and one simple path will be 1 and what do we say? 1, 3. Now let's come to this. Basically, this will have a simple path of its own, okay, and it will also have simple paths with both these values. So the other one will be 1, 2, and 3. And as you can see, this is how we, okay, but the one thing is that we measure. So basically, this one says that I can either come in the path or I can be excluded from the path. So basically, if we exclude this one, we will take these two values, which is 2 and 3. Okay, let's look at another example. Let's say we had a tree which was 1, this had 2, this had 3, and this had 4. Okay, now we know that this 2 can make a path of its own only. This 3 will make a path of its own. This 4 will make a path of its own. Okay, now let's see what happens when this 1 comes. When this 1 comes with this 2, it makes one more path. When this 1 comes with this 3, it makes one more path with 3. And when this 1 comes with this 4, it makes one more path with this. Okay. Now, in order to make a path, this one has only one option, that it can take either, like, it can take any two, like, what do we say, paths below this. Okay. So this one can either take this path or this path or this path. So basically, out of these three paths, in every chance it will take any two paths. Okay, so basically, let's say when this path takes 2 and 3. So when this path takes 2 and 3, it has two options. Either it should take both of them, or it can take both of them, or it can exclude itself. So basically, we'll have 1, 2, 3, or we have 2, 3. Right. Okay. The next option that one has is 1, 3, and 4. Now in this also, it can either take both of them or it can exclude itself. So we'll have 3, 4. The next option is that it can actually go for 1, 2, 4. From this also, it will either have a path with 1, 2, 4 or it will exclude itself. So it will have 2 and 4. Okay. Now, okay. Now there is one last option that is left, which is when this one comes alone. Okay, now as you can see, for this the answers become, so we'll have 6 values here, 7th is here, and then we have 6 more values. So basically this will give us 13. Okay, now let's see what happens when we introduce one more node to this 4. Okay, now what are the total number of paths that this 5 alone can make? It can make only one path. Now it says that my parent is 4. So what are the total number of paths that this 5 is able to make with this 4? It is 4, 5 or this 4. Now this 4 says that I alone can make one path only, and when taken with my child, I have these two paths as well. So let's say this was some unit and it could make these paths 4, 5 and 4, 5. Now if you see, everything runs the same way. How? Let me show you. So basically for 2 we had these two paths, for 3 we had this path. Now when we have these paths here, when we attach this one to this, it says that I can either attach myself to every path or I can keep myself detached with every path. So basically these three will be one option, or the other values will be 1, 4, 1, 5 and 1, 4, 5. Okay, now let's come on to this. It says that I was to go from 1 to 2 and 3. So this is that there is no interaction with this, so the answer for this will be this only. Now let's come on to 1, 3, 4. Now this 4 says that I am also attached to 5. Since I am also attached to 5, there are two options. Let's include one or let's exclude one. Okay, let's talk about excluding one first. Exclude one. When we exclude one, we know that 3 says that I am a set of 2 paths, and 4, 5 says that we have a set of 6 paths. So you can bring any one subset of yours and I will give you any one subset of mine. So basically it says that 3 says that I have two paths, and this says that I have 6 set of paths. So basically 2 into 6, which will say 12. They both say that in total we can make 12 different simple paths, set of simple paths. Now let's include one. When we include one, this one says that my total paths will be 12 only, but I will just include myself in every set. So therefore this will become 12 here as well. Similarly for this 1, 2, 4 as well, with exclude will have 2 into 6, which is 12, and for include will have again 12. Okay, and this is going to be the complete answer. Okay, let me just show this again. So basically, let's just say that we had a tree, we had one, and let's say it was attached to some subtree. This 2 was also attached to some subtree, and this was also attached to some subtree. And let's say that this subtree gave me x total number of paths, this subtree gave me y total number of paths, and this subtree gave me z total number of paths. Now this one will say that I have to take any two values and multiply them. So basically what we will get is we'll get xy when we take these two sets. Now these xy will be excluding 1, exclude 1. We'll have xy again when we include 1. So basically in total we'll have 2 xy. One xy is including this one and the other is excluding this. Okay. Then we will have yz. So we'll have 2 yz. One yz will be excluding 1 and the other will be including 1. Okay. And similarly we'll have 2 xz as well. So these are the total paths that we'll have from the roots. Now this one will say that I alone can be a path as well. Okay. And this set will say that I alone can be a path. So basically I can have x paths of my own as well. This will say that I can have y my alone paths of myself as well. And this will say that I can have z alone paths of myself as well. Okay. Now, so we can see that from DFS or any recursion, finding these values is easy. X, y and z. So basically all we have to do is when we reach 1, we have to add 1 plus sum of all the roots, sum of all the leaf values. So basically this will give us a sum of x, this will give us a sum of, this will give us y, and this will give us z. So we just have to add all the values. So this will x, y and z. We just have to add all these values. But how to find this? Because the reason is, what if instead of 3 there were 4 sets? Okay, if there were 4 sets, we had to take pair of every 2 sets. Okay, so let's look at something. Let me show you something which is actually something like with which you are able to solve this. Let's say there were 3 sets. First set was A, we had B and C, and we had to find the value of 2AB plus 2BC plus 2AC. Let's look at what is A plus B plus C whole square. This is actually A square plus B square plus C square plus 2AB plus 2BC plus 2C. Okay, we know what is this, because like we know that in every tree, like if this was a tree, we know this is A, this is B, this is B. We can just return this value. So basically we can count the sum here. And if you see, you can also count this. We have all the individual values. So let's say this value is square sum, which is A square plus B square. So basically if we have the total sum and if we subtract the square sum, then we will get all these values. So basically what we need to do, this actually works for everything. So even if we had like 4 values, if we had 4 values, then we had to calculate like 2AB plus 2AC plus 2AD plus 2BC plus 2BD plus 2CD. If you see, A plus B plus C plus D whole square is nothing but A square plus B square plus C square plus D square plus this complete value which is here. Okay, so this is nothing but sum square, this is nothing but square sum, and if you subtract both these values, you get this. So So no matter how many sets you have, you can just calculate sum square minus square sum, and this will give you the value of all the pair of 2's. Okay. Actually, if you even extend this, you can find the values of every 3 pairs as well. So that is something you can look after the stream if you want. This is very helpful. Okay. So what do we have here? So basically, what we need to do is, let's say this was the tree. Let's say this. What you need to do is, you actually need to come down to the, like, you need to run a DFS, and then we know that whenever you run you get a leaf node, you say that it returns 1. It also returns 1. Now, since this returns 1 and this returns 1, we can say that the sum of this is 2 and square sum is also, okay, I need to remove my picture for this, I think. Okay. And square sum will be 1 square plus 1 square, which again is 2. So I will say that the total number of nodes for this is actually going to be 1 plus sum minus square sum. Right. I hope I'm not missing anything. Let me just check. I feel like I'm missing something. Yeah, okay. Okay, cool. Okay. So basically, these are the total number of values that we had using this node. So now for this node, we had all these values. That it said that the total number of sets I can provide you is 1 plus sum minus sum square. Okay. I think, yeah, okay, cool. Okay. Just a second, I think there is some issue. Okay, yeah, cool, sorry. Okay. So this is the complete value. Now we will also say that we had these values as well. So basically the total values from this is actually going to be sum plus 1 plus sum minus square sum. So this, let's assume that this is some y value, and let's assume this also gave us some x value and this also gave us some z value. We can do the exact same approach for this as well. So basically for every node we need to just return the number of sets this alone was able to make. Okay, and how to do that? Basically we need to exclude all the simple paths from that. Okay, so how do we do that? So basically the tree was like this. Okay, so we know that in order to like return any value, so basically a certain set of values will be for this particular node only. Those values will be nothing but 1 plus sum minus square sum. What do these sum minus square sum have? This has all the values excluding this, and it has all the values including this. But this is something that we need to add in the answer, that because this is also a part of answer only, so we need to add this into the answer. But what is the value that this is going to return? This node is going to return that I can give you either 1, which is alone myself, or sum minus square sum by 2, which is actually, let's say there were 3 values x, y and z. So this is actually, oh sorry, which is actually 1 plus sum, because basically we know that this set can give us x values. So it will say that I can either include these x values or exclude these x values. Okay, so including x values will give me x number, including 1 with these values will give me an x, excluding these will also give me an x. Then I can have some simple paths from this y, that if I include myself, then I will have y paths. If I exclude myself, I will again have y paths. For this also I have z paths, and when I include myself, I have z paths. So basically we know that this will be 2 times x plus 2 times y plus 2 times z. So in total, we will return 1 plus 2 times of sum. These are the total number of paths that this node will be able to make. But this is something that this node will return to its root. Apart from this, we'll also have like this added into the answer. The reason is because this alone could have also made complete paths, and they would have been like we already calculated that basically those were this is okay, and this alone can be a path as well, so that's why 1. So let me show the code. Okay, so basically let's see like what I am doing. So basically so there is nothing much here, I'm just pushing all the edges and everything, and then in the end I'm actually calling a DFS from 1. When I call this DFS, if you see, whenever I get a value, I add it to the sum, and I also calculate a square sum, which is nothing but value into value. Okay, so and then I calculate the mod of these values. So after this loop, basically when I'm at this node, I know the sum of this and the square sum of this. Now we need to like, okay, so basically in the answer we are adding sum square minus square sum, because this is what, okay, I'm forgetting square. So basically, because that is actually going to give me this, the total number of paths we could make from this, right? And after that, we will just return 2 times sum plus 1, which is here. That these are the simple paths in like one direction only. So basically, these were actually in which we were bending like this. So basically, we took something from this set and something from this set. Okay, but whenever we calculate the value of sum only, that means we are only considering one set. So basically, they will have an alone path, like a single path as well, and we'll return all those to the previous one because that complete makes a set. So I'll just return this 2 into sum plus 1, and then in the end, I'll just like print the answer. So like there is a very simple idea. So basically, all you had to know was like first see that what all things you have to return and what all things are going to come in the answer, and then you just have to like know a method how to calculate this, because these sets at max could have gone to n, and calculating this would have gone to n square. So you need to know an efficient way to do this. Okay, and this is how you do this. Actually, like this is the beauty about long challenges, I would say, because like this is something which I did not know like 6 months back, and if I also like I can even show that to you. So what okay, so I remember there was this problem related to triangles in some long challenge. If I go to my own long challenge, okay, this is the last long challenge that I gave in August, actually in August 2020, in the long challenge. Okay, I think okay, yeah, this was the question, insanely hard. So if you look at this problem, this is actually related to some triangles, and if I show you my code of this, I did this exact thing. So basically in that, what I had to do was I had to find every 3 pairs, ABC, BCD, and ABD, and every like a pair of every 3 values I had to see. And to do that I just googled, since this was a long contest, I just googled everything and find out. So this is where I do that. So like this was a bigger idea, and this was used here. So this is the like beauty of giving like consistent contests and everything. You just gather so many things. So because I did not take much time in solving this question, and the only reason was because I knew how to do this. Otherwise, I know I might have spent a lot of time. So all you had to do is be consistent. Okay. All right. So we are almost 100 minutes around, and we are done with all the problems that we had to discuss. We discussed 7 problems, I think 5, 6, 7. Yeah, we did discuss 7 problems, and I will still say that there was a lot of cheating this time, because I don't understand like the number of count. In Dev 1, if you see, there is a very lesser count because like they people don't cheat. But yeah, anyways, I hope you enjoyed the stream. Like the stream, subscribe to the channel if you are not subscribed yet. And if you have any questions, you can ask me in the comments, or I'll just drop the Discord link somewhere in the comments so that you can join. Okay. Okay, cool. I think that's it. Okay. All right. I'll end the stream now.